Hi guys, welcome to lesson 6.5, Linear Inequalities. Our objective for today is that I can graph the solution of linear inequalities into variables. So let's just start off with the definition. A linear inequality into variables can be formed by replacing the equal sign with an inequality symbol. The solution of a linear equality is any points that satisfy the inequality. All right, so there's lots of solutions to these kinds of problems. So we're going to start off by just identifying, first of all, is a coordinate a solution to an inequality? So we start off, we're going to substitute the 3 and the 6 in for y and for x in our equation. So 6 is going to be less than or equal to 2/3 times 3 plus 4. Well, 2/3 times 3 is just 2 plus 4. So is 6 less than or equal to 6? Yes, it is. Okay. We're going to do the same thing, plug in -5 and 2 for x and y. So 2 is going to be less than -5 plus 2. So is 2 less than -3? No. So that is not a solution. Want you guys to try letters C, D, and E on your own, and then we will go over them. All right. So we have -1, 4. We're going to substitute that for x and y. So 4 is less than 2 times -1 plus 5. So 2 times -1 is -2 plus 5. Is 4 less than 3? No. Is 4/6 a solution for y equals, or is greater than or equal to x plus 2? So we plug in 6 for y is greater than or equal to 4 plus 2. Is 6 greater than or equal to 6? Yes, it is. So the question that E asks is, if an ordered pair is not a solution for y equals x plus 10, must it be a solution for y is less than x plus 10? Well, no, because it could be equal to. So we have an example. I have the coordinates 2, 12, and we're going to use that equation. So if I plug in 12 is greater than 2 plus 10, well, 12 is not greater than 12. So if we plug it into our second equation, 12 is less than 2 plus 10. 12 is not less than 12. So that would be an example where we have an ordered pair that is not a solution to either one, and it's because that is a point that lies on the line. So when we only have less than or greater than, the points that are on the line are not part of our solution set, which we're going to talk about a little bit more as we graph them in the next problem. All right, so problems 2 and 3 are graphing a linear inequality. First thing we need to do is identify the slope and the y-intercept of our line. So we have it in slope-intercept form. My slope is a positive 1/2. My y-intercept is 1. So I'm going to graph that positive 1 and my slope of 1/2 up 1 and to the right 2 every single time. Okay. Now, if it is less than or greater than, we're going to use the dashed line, and the points on the line are not part of the solution. That's what we got at the end of problem number 1. We could think of this as being the open dot from our chapter 3. If it is less than or equal to or greater than or equal to, we use a solid line, and those points are part of the solution that are on the line. So that would be a solid dot, and that's just a mistake. All right, so our inequality symbol is less than or equal to, so we are going to draw a solid line, so make sure you use a straight edge. Okay, so we have our solid line drawn. Now, our next point, or our next step, is to identify a test point and substitute it into the inequality. If it is a solution, we're going to shade the side of the line with the point. If it is not a solution, we're going to shade the opposite side. So the test point that I always like to use, and as long as you don't have a proportional relationship, it's the one you should use, is 0, 0. Why do I like using 0, 0 so much? Because it makes my math really easy. Because variables cancel out. Is 0 less than 1? Yes, it is. So the side of my line that has the test point is going to get shaded in. Oh yeah, by the way, you're going to need colored pencils or something for this lesson. Okay? So any point that is in this green region, absolutely any one of these points would make this inequality true. If I plugged in 5 for, no, let's go with 6 for x and 0 for y. 6 times 1/2 is 3, plus 1 is 4. Is that greater than or equal to 0? Yes. Any point in this shaded region is a solution for that inequality. So let's do a couple more practice problems. Letter A, we have y is less than x plus 1. So we're going to start by graphing our line. So we have a y-intercept of 1, and we have a slope of 1. Okay, and I have a less than symbol, so this is going to be a dashed line. So when you draw a dashed line, it should just be broken. So there's no set pattern of how long each of your pieces should be, but you should clearly see that it is not a solid line. There are gaps there. So a point that is directly on one of those, or anywhere on that line, is not part of our solution set. So I'm going to use my traditional test point that I personally like, which is 0, 0. So is 0 less than 0 plus 1? Well, is 0 less than 1? Yes, it is. So we're going to shade that side of our graph. So again, any of the points that are in this shaded region could be potential solutions for this inequality. All right, letter B, we've got y is greater than or equal to 3x plus 2. So I have a y-intercept at positive 2. And my slope is 3, so we're going up 3 and over 1. Up 3 over 1. And it is greater than or equal to, so we can draw a solid line. So points on the line are part of the solutions. And we're going to use 0 for our test point. So is 0 greater than or equal to 3, or 3 times 0 is 0, plus 2. Is 0 greater than or equal to 2? No, it is not. So we are not going to shade the side with 0. We need to shade the opposite side. And you can use any test point you would like. I just like to use 0, 0 as my test point because, quite honestly, it makes the math easy because everything cancels out when you multiply by 0. So I really didn't have to do any thinking. I knew that term was gone already. All right. I want you guys to try letters C and D. Actually, no, we'll do, yeah, you guys try C and D on your own. So y is less than or equal to 2/3 x plus 1. So we have a y-intercept at 1. A slope of 2/3. And it is less than or equal to, so it's going to be a solid line. Plug in our test point of 0, 0. 0 is less than or equal to 1. That is true. So we will shade that side of our line. Okay. Letter D. y is greater than negative x plus 4. So we have a y-intercept at 4 and a slope of negative x, negative 1. So we're going down, and it's greater than, so it's going to be a dashed line. So make sure your line has some breaks in it. And we plug in our test point. Is 0 greater than 4? No, it is not. So we are going to shade above this line. We're going to shade the side that doesn't have 0, 0 in it. All right. Next page, we have some more examples. Yay! All right, so we have x is less than negative 5. So remember, when it's x is equal to, it would be a vertical line. So we have less than negative 5. So we have a point right there. And it's less than, so it's going to be a dashed line. So we have something that looks like this. All right. And it is less than. So again, we can plug in that test point of 0, 0. Is 0 less than negative 5? No, it's not. So we need to shade to the right. Letter F, we have y is greater than or equal to 2. So we have a point at 2. And it's greater than or equal to, so it's a solid line. And it is greater than, so it is going to be shaded above. Okay. All right, so I want you guys to try letters G and H on your own, and we'll go over them. So letter G, we have a point at positive 3. We have a slope of negative 2, so it's going down 2 to the right 1 every single time. And it's less than or equal to, so it's going to be a solid line. Okay, so now we have our test point of 0, 0. Is 0 less than or equal to 3? Yes, it is. So we shade below the line. Has anybody started to notice a pattern of when we shade above and when we shade below? There is a pattern. All right. Letter H, we have x is greater than or equal to 1. So we have a point at 1. It's greater than or equal to, so it's going to be a solid line. And is 0 greater than or equal to 1? No, it is not. So we shade to the right. Okay. All right. Now, moving on to the last section in our notes. We have to write some equations first, and then we need to graph them. So, for a party, you have budgeted no more than $12 to buy mixed nuts. Peanuts cost $2 per pound, and cashews cost $4 per pound. What are 3 possible combinations? So, one equation is going to be $2 per pound times the number of pounds of peanuts, x, plus $4 per pound times the number of pounds of cashews, y, has to be, let's see, budgeted no more than $12, so it's going to be less than or equal to 12. Our second equation, or sorry, no, not our second equation, that's it. Only one equation. Tomorrow we'll deal with 2 equations. Ha 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 ha. Okay, so we have peanuts on our x, cashews on our y, and we're going to go by ones on our axes. So we need to find our intercepts because we got a standard form equation, so let's find our intercepts. So 2x is less than or equal to 12, so x has to be less than or equal to 6. And we have 4y is less than or equal to 12, so y has to be less than or equal to 3. So we have a point at 3 on our y-axis, 6 on our x-axis. It's less than or equal to, so it's a solid line. And we are shading below it. Okay. So what is a possible combination? Well, you could have either of your two intercepts. You could have a point there. You could have a point there, there. All of those are potentials, and anywhere in between, because you could buy a fraction of a pound of peanuts. All right, so letter B, we have suppose you can spend no more than $40 for hot dogs and hamburgers at a picnic. Hot dogs are $5 a package. Hamburgers are $8. So we've got hot dogs. We've got burgers. Could use a barbecue right about now with the weather as cold as it is. And again, we're going to do 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. But now I need to have an equation. So hot dogs cost $5 per package, 5x, plus hamburgers are $8 a package, 8y, has to be less than or equal to the $40 budget. So now let's find our intercepts. 5x equals 40. So x is going to be equal to 8. And 8y equals 40. Sorry, less than or equal to 40. So y is going to be less than or equal to 5. So my y-intercept is 5. My x-intercept is 8. It is less than or equal to, so it's a solid line. And we are shading below it. Okay? So again, any of the points that are inside here. Now on this one, we would have to go with full packages of hot dogs and hamburgers, so it's only going to be our full points. Okay, last problem, since the Cubs, well, they did not win the World Series this year. All of the other playoff gear is clearance at the stores. T-shirts are $5, hoodies are $10. So if T-shirts are X, hoodies are Y, 5X plus 10Y, and I only have $50 to spend. Definitely spent more than that on my World Series gear. Is less than or equal to 50. So again, let's find our intercepts. 5x is less than or equal to 50. So x is less than or equal to 10. So 10 t-shirts, or 10y is less than or equal to 50. So then y is less than or equal to 5. So I could do 10 t-shirts or 5 hoodies. I mean, $10 for a hoodie, that'd be a sweet deal. T-shirts, hoodies. Again, we're going to go by 1. So 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. We said my x-intercept was 10, so there's a point right there. My y-intercept was 5, so I got a point right there. And it is less than or equal to, so it's a solid line. So I could have anywhere down below here. Okay. So if we look at points, I could have bought one hoodie or one t-shirt and 2 hoodies, 2 t-shirts, 3 hoodies, 3 t-shirts and 2 hoodies, any of these points. And again, these points, you're only going to be using the whole numbers as potential solutions because you cannot buy half of a t-shirt or half of a hoodie. All right? So these are, that is graphing inequalities. Tomorrow we are going to do, we got to write systems. Oh, I forgot about this one. All right, so what is my y-intercept for this graph? I have a y-intercept of -2. My slope, we are going up 1 and over 3 each time. So it's 1/3 x. y. Now it's going to be, we are shading above, so here's the hint, if you're shading above, it's going to be greater than, and it's a dashed line, so it's only greater than. All right, so letter B is a solid line with a y-intercept of 3, a slope of 1/2. We're going up 1 and to the right 2 every time. So it's 1/2 x plus 3. And it is below, so it's less than, and it's a solid line, so it's less than or equal to. Letter C, I want you guys to try C and D on your own. Letter C has a y-intercept of -1 and a slope of 1/2, so it's 1/2 x minus 1. We are shading below it, so it's going to be less than, and it's a dashed line, so it's just going to be less than. So letter D, we know the boundary line is dashed, so it's going to be either less than or greater than. It has a slope of 7, so we can say 7x. A y-intercept is -2, 7x minus 2. And we are shading above the line. So it's above the line and dashed, so y is going to be greater than 7x minus 2. All right, now we are done with this lesson. Write down any questions you may have come up with. Make sure that you give yourself a rating on your level of understanding of this lesson. And write down a summary of what we did in order to graph and solve linear inequalities. Tomorrow, or not tomorrow, whenever we get to the next lesson, after map testing, we are going to do systems of linear inequalities. So just make sure that you are catching on to this material. Make sure you ask any questions if you have them. And we will see you all in class. Have a great night.